When we think of bringing new products to market quickly and profitably, in most cases, it all starts with a customer request. In this example, we're going to be working with a robotic welding cell, and our customer has a request for a high-mounted robotic welder, and we need to design a brand new structural frame that's going to meet the customer demands. We want to make sure we always start inside a vault. This ensures all of our data is not only secure, but also managed effectively. When we open from Vault, we'll check out all the related components. This ensures no one else is editing the files at the same time. We'll start with one of our customizable iLogic assemblies. This will help us automate the design process and save valuable engineering time. iLogic allows us to explore different design combinations in real time. We can adjust height, width, depth, the top angle, even suppress the front braces if we think we don't need them. Once we have all of our customer requested design options input, we can save the new assembly and check it back into the vault. An alternative way to explore new design options is to work with the same iLogic form, but to use a drawing template. This would be a great way to quickly respond to RFQs and have drawings automatically generated in minutes rather than days. Simply input the customer requested options, adjust updated dimensions, and now that we're all done, we can check our data back into the vault and move on to the validation part of our design workflow. Because we're using the Product Design and Manufacturing collection, we can use Nastran InCAD right inside of the Inventor user interface. Once we get into the Nastran InCAD environment, we'll start to set up our simulation. Since we're working with plate and structural steel tubing, we can simplify our model down to mid-plane surfaces. This allows for the same accurate results in a fraction of the time. Working from left to right, we'll add 4 fixed constraints to the bottom feet. Next, we'll add 20,000 Newton load to the top surfaces. This represents the robotic welder, and we'll have this go in the negative Z direction. Since we're working with surfaces, we'll set the contact to offset bonded and make sure that we capture a max activation distance of 15 millimeters. This ensures all of our surfaces are in contact. Inside of our mesh settings, we'll adjust the element size to 40 and click Generate Mesh. Using a finer mesh will give us a better resolution, and since we're working with surfaces, it will still run extremely fast. Now that our mesh is generated, all we need to do is run the simulation. After our simulation is complete, we can adjust some of the visibility options and uncheck undeformed edges and mesh. Next, we can animate the results, and keep in mind the deformation you see is exaggerated to better help identify areas of interest. As we take a look, the von Mises stress is well under the yield of our steel material. We'll also look at the maximum amount of deformation to see how much the frame is moving. The results show our frame is moving less than a millimeter. Now let's take a look at adding the front braces back in and see how much we can improve the design. We'll copy the analysis and all of the setup is copied over. All we need to do is add the front braces back in, make sure we capture the new surfaces, remesh, and run. When we take a look at the results, we can see that we cut the displacement in half as well as reducing the von Mises stress. Now that we've validated our design, we can get everything back into Vault and move on to the next step of our design process.